All right, we're going to now go through our numbers and look at all of our different types of numbers together at once. So we're going to start with complex numbers. Complex numbers are all known numbers. Okay, this could be real numbers, such as a natural number, 1, a whole number, 0, a rational number. Well, I forgot integers, so we're going to add an integer here, -2, a rational number, 2/3, an irrational number, pi. This includes imaginary numbers like the square root of -4, or any combination of these numbers together. All numbers are complex numbers. All right? Now, imaginary numbers are specifically the result of taking the square root of any negative number. Any negative number. So the square root of -4, the square root of -2. If you do the square root of -pi, the square root of any negative number is going to be imaginary. Okay. So numbers can either be imaginary or real. All of these are going to be complex numbers. Everything's, well, I'm not going to write that line there. Everything's a complex number. But within complex numbers, they can be imaginary or real, or if they have a real part and an imaginary part, we call it complex. Okay? So, number can be imaginary or real. Real numbers are all non-imaginary numbers. Okay? Or the square root of any non-zero. Really, any real number could be expressed as the square root of a non-zero number. You might say, well, what about 9? Well, that's the square root of 81. What about 2/3? That's the square root of 4/9. So that's another way we could look at real numbers. Any real number is a square root of, not a non-zero, a non-imaginary, because we can also have a non-negative, my mistake, non-negative. Not a non-zero, because the square root of 0 is 0, which is also real. Okay, so I'm going to write some of those examples down. For instance, the square root of 9, which is 3, the square root of 2, which is just radical 2, or I could have, for instance, the square root of 4/9 is 2/3. Now, we'll look at how we take these square roots in a separate lesson. I don't expect you to do this math. I just want us to recognize the numbers. Okay. So all of our non-imaginary numbers or a negative number, so -3 and so forth. Then, of our real numbers, all those numbers can either be irrational or rational. Okay? Irrational numbers are a square root of a non-perfect square. Okay? Anything that's a square root of a number that's not a perfect square. So that's our radical 2, radical 8. By the way, it has to be a positive one. Radical 4.1 would all be irrational because those numbers are not perfect squares. Okay. And these can also be negative as long as the negative's in front, so negative radical 3, for instance. I'm going to do rational numbers. I'm going to pause for questions. Rational numbers are going to be the square root of a perfect square okay? Or a ratio, a fraction of two integers. Okay, an integer over an integer. So for instance, radical 4. Again, positive perfect square. Rational and irrational have to be positive numbers. Square root of 4, 2 over 3. Negative 1/2. I'm going to pause. I'm going to go back up, and we need to add to irrational pi. That's our special irrational number. Anything with a pi in it is an irrational number. Okay, so I'm going to pause here. Other than where's integers, because I'm missing it on the set of notes, we'll add it in. Any questions on our notes so far? Okay, so integers, we'll just kind of slide this in here. Integers. I'll take your questions in a second. All right, type of rational number, and then all whole and natural numbers are integers. And integers are positive and negative whole numbers. Okay, whole numbers are counting numbers plus 0. So 0, 1, 2, 3, and so on. Natural numbers are just our counting numbers. Integers include our negatives. -3, -2, -1, and our positives. So forth. All right, any questions about a slide number? Maybe kind of go up?
I just wanted to get
Yeah, go ahead. All right, I'll leave this up for a moment, and then we're going to go down and work on our diagram. So take a moment, make sure you have that. All right, so as a diagram, and I need to zoom out just a little bit, we want to make our outermost box as big as possible. So use up all of that space there. Okay, but outside of our biggest box, just do the black box right now. Don't do the inside ones because that'll get you confused. So we're outside of our biggest box. We're going to call this whole sheet of paper the complex. We use a C. The complex set of numbers. Okay, and we're going to draw a small box outside of the big box, and this is our imaginary. So complex includes imaginary, that's the I, by the way. And then our big box is R for real. So complex is real and imaginary. And then anything that's a combination of a real part and an imaginary part is complex. Okay. All real numbers have either a rational part or an irrational part or both. Our rational, we use Q to represent because we already used R for real. Yes, ma'am. You don't have to. I do it so it's a little bit easier for you to see and so I can refer to it. So my blue box is rational. Great question. My green box over here is, I for irrational. I forget what imaginary is. It's not I. Irrational. Okay? So our irrational numbers are non-repeating, non-terminating decimals. Such as radical 2, 1.4142135 6 2 just goes on as much as you can fit in there is the idea. We put what we can fit, and what we can't fit is a dot, dot, dot. And goes on. Or pi is a special type of irrational number that we call a transcendental. The cousin of pi, by the way, is e, which is the base of a natural log. That's an Algebra 2 concept, so don't worry about it. Okay. Pause there for a moment. Right. Our rational numbers include all of our integers. The red box is z, integers, plus any number that's a ratio of two other numbers, such as 1/2, or its terminating decimal equivalent, or say -2/3, or its repeating decimal equivalent. Integers include all of our W, whole numbers, as well as the negative versions of each whole number. And our whole numbers include all our, one more box here, natural, that's n, which is 1, 2, 3, dot, 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 and so on, and the number 0. So whole is just natural plus 0. All right, how are we doing? Okay, that's the conclusion of these notes. I'm going to end our recording, and then we'll practice this.